You know, we hear all the time about AI models getting bigger and bigger and bigger. But what if that's the wrong approach? What if the real key to genuine reasoning isn't about brute force, but about a smarter, more elegant, brain inspired design? Well, today, we're going to look at a new AI that might be exactly that, a total revolution in how machines actually think.
And it all kicks off with this really simple but kind of mind-blowing question. We've got these gigantic AIs, right? They're trained on pretty much the entire internet, all of human knowledge. So why on earth can't they solve a tricky Sudoku puzzle? I mean, really think about that. It seems crazy, but it points to a huge fundamental flaw in how we're building AI today.
Yeah, and that right there, that's what we're calling AI's reasoning problem. You can picture today's big models, the LLMs, as these powerful but seriously flawed giants. They're incredible in some ways, for sure, but deep down, their basic design has this one critical weakness. So, here's how you can break it down. On one side, you've got your typical LLM. The way they're built is fundamentally shallow. To solve something hard, they have to literally write out their thinking step by step. You've probably heard of this. It's called chain of thought. And look, it's a neat trick, but it's fragile. It breaks easily. But then, on the other hand, think about how we think. Real deep reasoning happens inside our heads, in this abstract thinking space. Scientists call it a latent space. It's fast, it's efficient, it's robust, and it's exactly what these big models just don't have.
And the folks who built this new model, they don't pull any punches. They say it flat out. Chain of thought, that thing that makes chatbots seem so clever, it's just a crutch. It's not real thinking. It's a Band-Aid slapped on a fundamental design flaw, and it's never going to lead to genuine reasoning.
Okay, so if the current way is broken, where do we look for a better blueprint? Well, it turns out we've had the perfect example right here the whole time. It's the most powerful, most efficient reasoning machine on the planet, the human brain. Think about it. We don't need to read the entire internet to learn how to solve a puzzle.
And when you look at the brain, scientists have found it runs on a few key principles. First, there's hierarchy. You've got high-level parts for big-picture, abstract planning, and low-level parts for crunching the details. Second, these parts work at different speeds, kind of like slow and fast brainwaves. And third, there are constant feedback loops, so the brain is always checking in with itself, refining its thoughts. It's this beautiful, dynamic system, and it's the very blueprint AI has been missing.
So what happens when you take that blueprint and build an AI with it? Well, that's where our hero of the story comes in. It's called the Hierarchical Reasoning Model, or HRM for short, and you can think of it as the clever underdog, built from scratch based on those exact same brain principles. And the way it's built is actually pretty simple and elegant. The HRM basically has two main parts that are constantly talking to each other. You've got the high-level module, let's call it the CEO. It's the slow, big-picture planner. Then you've got the low-level module. That's your engineering team. They're the ones doing all the fast, detailed work to actually get the job done. Now, the real secret sauce here is how they work together. It's this process called hierarchical convergence. Basically, the CEO gives a goal. The engineering team crunches the numbers and works like crazy until they solve that one specific piece of the puzzle. Then they report back. Done. The CEO takes that result, comes up with the next step, and the cycle starts all over again. It's this plan and do loop that lets the model think really, really deeply without just getting stuck or confused. And here's the part that's just wild. This thing is tiny. It's only 27 million parameters. To put that in perspective, that is thousands, literally thousands of times smaller than something like GPT. And it learned all this complex reasoning stuff from scratch. No giant pre-training dataset, just about 1,000 examples for each task. It's a perfect case of smarter, not bigger. Okay, that all sounds great on paper, but the million-dollar question is, does it actually work in practice? Well, it's time for the showdown. We're putting our clever underdog in the ring against the flawed giants to see if this brainy new design can actually beat the brute force Goliaths.
First up is a benchmark called ARC-AGI. This is a tough test of pure abstract reasoning, what you might call fluid intelligence. And, check this out, the tiny little HRM scores over 40%. That's not just a little better, it's way better than much, much larger state-of-the-art models.
But now for the big one. Remember that hard Sudoku puzzle we started with? Researchers took an extremely difficult version of it and threw it at the world's best AIs. After all that training, all that data, their accuracy was 0. A big, fat 0%. They couldn't solve a single one. Not one.
And the HRM? 55%. It solved more than half of them. I mean, that's not just an improvement. It's a completely different universe of capability. When the giants fell flat on their face, the little underdog showed it could actually think its way through the problem.
All right, so was Sudoku just a lucky shot? A fluke? Let's try another really hard reasoning task. Finding the single best, most optimal path through a really complex maze. This is tough. It takes planning, memory, backtracking, actual logic. And the big models? You guessed it, 0. Again, we're definitely seeing a pattern here.
The HRM, though, it finds that perfect path almost 75% of the time. The difference is it's staggering. It's proof that for these kinds of really hard reasoning problems, this new architecture is playing a completely different game. So, okay, we've seen what it can do, but honestly, the more interesting question is how. How is this even possible? And the answer is amazing. It takes us out of pure computer science and deep into the world of neuroscience.
To get our heads around the how, we need this one concept from neuroscience. It's called the participation ratio, or PR. The simple way to think about it is, it's a measure of how rich or complex a network's thinking space is. A higher PR means it's using a bigger, more flexible mental workspace, which lets it tackle more complex ideas. It's a hallmark of the really advanced parts of our own brains.
And this is where my jaw kind of hit the floor. The researchers measured the PR for both parts of the HRM. And they found that the high-level CEO module had a thinking space that was almost 3 times richer than the low-level engineering module. But here's the kicker. That ratio? It's almost exactly the same ratio you see between the high-level and low-level areas of a real biological brain, like in a mouse. And this is the single most important part of the whole thing. The HRM wasn't told to organize itself like a brain. It figured it out on its own. Just by trying to solve these hard problems, it discovered that the most efficient way was to develop this brain-like hierarchy, to give its CEO a much richer thinking space. That structure wasn't designed in. It was an emergent property. It just happened as a result of learning to reason. Which brings us to one last really big thought. It looks like this little AI didn't just copy the brain's design. It seems to have independently discovered a fundamental principle of how intelligence works. It stumbled upon a universal blueprint for computation. And that leaves us with a huge question. Have we just found the brain's actual blueprint for creating an AI that can truly think?